Good day, my students. Welcome to my class. I am your teacher, Juni Castigon. So our first lesson for this school year is about generating pattern. As you can see here, what there's a question: what will come next in this pattern? So we have here a triangle, two green triangles, then we have upside down yellow triangle, and so on. So at this lesson, we'll be able to generate pattern because the objectives for today is generating patterns. Okay, I want you to look around where you are now and find something that has a pattern and answer these questions. How are the designs from around the world formed? Second question, how many patterns form? The third question, where can we see patterns? And the fourth question, and how will you complete a shape or a number pattern? These questions will be answered right after the discussion of this topic.
Today we will be discussing about generating patterns. So our objective for today is very simple, to generate pattern. So before discussing what pattern, the different patterns, let's identify first, or let's define first what a pattern is. A pattern is an arrangement that we usually found in a comparable object. Example, let us consider the wheels in a vehicle all over the world. When we say wheels, it's around, right? So the pattern is very simple and it's very common sense. However, let's take for instance a t-shirt. It has 4 holes. One for your torso, second is for your neck, and the other 2 holes are for your arms. So what is the relationship between this pattern in mathematics? In mathematics, we have number patterns. Number patterns is a set of number that follows a certain pattern. And the one example of the common example of number pattern is the counting numbers. Like for example, from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And every sequence, or in every members of the sequence, it follows a pattern. So that is why the rule is n. So in every term of the sequence, like 1, 2, 3, 4, 5, and so on. So in every term of the sequence, there is a certain pattern, or there is a certain rule. So that is generally n. N means the first term, the second term, the third term, the fourth term, and so on. So in mathematics, we call this one as sequence. A sequence is a number pattern that follows a certain pattern. For example, 3, 5, 7, 9, and so on. This is a sequence of number. Now, let's try to identify the pattern of this sequence. From 3, why it became 5? From 5, why it became 7? From 7, why it became 9? Let's try to check what's the pattern. So maybe we add 2 here. So we add 2 from 3 to get 5. We also add 2 from 5 to get 7. We also add 2 from 7 to get 9. So therefore, So the pattern here is we keep on adding 2 to get the next number. So in this sequence, we keep on adding 2 to get the next term. Let's take another example. 2, 4, 8, 16. Let's try to identify the pattern of this sequence. What did we do to 2 that becomes 4? What did we do to 4 that becomes 8? What did we do to 8 that becomes 16? Maybe did you add 2 to become 4 here? We will add 4 to become 8. And here we will add 8 to become 16. Now this pattern is, let me say, difficult, because if you keep on adding 16 here the next term to get the next term, then the pattern is increasing. I mean, it's difficult. So we can, in getting the pattern, it's not about addition only. We can also use a combination of subtraction, multiplication, or division, or any other techniques. So in here, let's find another pattern. Let's try multiplication. What did we multiply to 2 that becomes 4? So that's times 2. What number do we multiply to 4 that becomes 8? Still 2. What will you multiply to 8 that becomes 16? Still 2. So I see pattern here. That means if we keep on multiplying 2 to get the next term. So in mathematics, there are many different types of sequences, like arithmetic sequence, geometric sequence, harmonic sequence, and Fibonacci sequence. There are also books that consider another sequence like square sequence, triangle sequence. There are a kind of sequence here. This is what we call the infinite sequence. Infinite. When we say infinite sequence, it continues on because of these 3 dots. These 3 dots is called ellipses. That means if the sequence contains 3 dots or ellipses, that means it is infinite. While this second sequence is finite sequence. There is no ellipsis that becomes finite. That means it ends with 16. There are only 4 terms here. It ended here. So that make this sequence a finite sequence.
What you have learned by completing the following statements. A sequence is a number pattern in which it uses a certain rule. It could be addition, subtraction, multiplication, or division, or any other techniques. And a sequence could be in a finite or finite when it ends. It has no ellipsis symbol. And when can we say that it is also infinite? It is infinite. It is infinite when it has ellipsis symbol. And these 3 dots are the ellipsis symbol.
Okay, this time let's try generating patterns. Let's start with number 1. Start with 288 and use the rule divide by 2. Here, the first term is 288. Again, the number in each sequence are called terms. So the first term is 288. Since the rule is divide by 2, so we will divide 288 by 2, and that is equal to 144. Next, 144 divided by 2, that is 72. Next, 72 divided by 2, that is 36. 36 divided by 2, that is 18. 18 divided by 2, that is 9, and so on and so forth. We keep on dividing 2. Okay? So this sequence is an infinite sequence because of the ellipses. Okay, let's try number 2. Start with 2 and use the rule add 3 then multiply by 2. So the first term here is 2. Since the rule is we will add 3 then multiply by 2. So 2 plus 3, that is 5, times 2, that is 10. Next, 10 plus 3, that is 13, times 2, that is 26. 26 plus 3, that is 29, times 2, that is 58. 58 plus 3, that is 61, times 2, that is 122. 122 plus 3, that is 125, times 2, that is 250. 250 plus 3, that is 253, times 2, that is 506, and so on. Okay, let's try number 3. We have here the sequence 15, 19, 23, blank, 31, 35, blank, blank, 47. Let's identify the rule for this sequence. What do you think is the rule for this sequence? So we have here from 15, it became 19. From 19, it became 23. So in here, we add 4, right? So 15 plus 4, that's 19. 19 plus 4, that's 23. So that means in here, 31 plus 35. 31 plus 4, that's 35. So the rule for this sequence is plus 4. So by continuing the pattern, so 23 plus 4, that is 27. 35 plus 4, that is 39. And 39 plus 4, that is 43. So far, so good. So how about trying number 4? In number 4, we have here 58, 52, 46, 40, blank, blank, 22, 16, blank, blank, a blank 4, negative 2, blank, negative 40, negative 20, and so on. So let's identify the rule for this sequence. What do you think is the rule? So from 58 became 52, from 52 it became 46, from 46 it became 40. So what happened? So the rule is we subtract 6 in every term. So 58 minus 6, that's 52. 52 minus 6, that's 46. 46 minus 6, that's 40. 40 minus 6, that's 34. 34 minus 6, that's 28. 16 minus 6, that's 10. Negative 2 minus 6, that's negative 8. So, negative 14, negative 20, and so on. Okay, let's try the last number. Number 5. The rule, what is the rule for this sequence? 2, 16, 14, 30, blank, blank, 2, 5, 4, blank. Now, let's try to find out the pattern. So when we use addition, does it work? 2 plus 4, that's 6. 6 plus 8. Okay, doesn't work. Let's try to find another pattern. Let's say multiplication. When we multiply 2 by 3, that becomes 6. 6 times 3, that's 18. It's not 14. So maybe in this sequence, there are 2 operations. So maybe like, let's try to add 1 and multiply it by 2. 2 plus 1, that's 3, times 2, that's 6. Correct. Another. 6 plus 1, that's 7, times 2, that's 14. 14 plus 1 times equals 15, times 2, that's 30. So the pattern works for the four terms here. So therefore, the rule for this sequence is plus 1, then times 2. So let's continue the pattern. 30 plus 1, that's 31, times 2, it's 62. 62 plus 1, 63, times 2, that's 126. 254 plus 1, that's 255, times 2, that's 510, and so on and so forth.
So let's discuss the first type of sequence, which is arithmetic sequence.
Okay, what is an arithmetic sequence? Arithmetic sequence is pattern of numbers that increase or decrease at a constant amount. For example, 2, 4, 6, 8, 10, 12, and so on. This sequence is an infinite sequence, and this is also arithmetic sequence. Why this is arithmetic sequence? This sequence is increasing at a constant amount. When you say constant amount, because when you go to 4, from 2, you add 2. When you go to 6, you add 2. From 6 to 8, you add 2. From 8 to 10, you add 2. From 10 to 12, you add 2. So there is a constant amount that you've added to all the sequence, to all the terms of the sequence, and that is why this is an arithmetic sequence. Okay, what is common difference? Common difference is a constant amount of change. Amount of change between numbers in a sequence. We will get the differences between the terms of the sequence. If the differences of the sequence are the same, then that is the common difference. See, for instance, 2, 4, 6, 8, 10, and so on. Like for this sequence 2, 4, 6, 8, 10, and so on. It is a sequence of positive even integers. So we are going to find the common difference or the constant amount of change between numbers in a sequence or between terms in each sequence. Now, so we will get the difference from 2 to 4, 4 to 6, 6 to 8, 8 to 10, and so on. In getting 4, we add 2. In getting 6, we add 2 to 4. In getting 8, we add 2 to 6. In getting 10, we add 2 to 8. So therefore, this constant amount is the common difference. Then the common difference is 2. Okay, this time let's find the common difference. For example, 2, 4, 6, 8, and so on. Now in getting the common difference, let's write out first the sequence. 2, 4, 6, 8, and so on. In getting the common difference, so let's find the difference. The difference. So in getting 2 to 4, we need to take 4 minus 2. In 4 to 6, we need to take 4 minus 4. In 6 to 8, we need to take 8 minus 6. So by getting the difference of this, 4 minus 2 is 2, 6 minus 4 is 2, and 8 minus 6 is 2. Therefore, the common difference is 2. And we denote the common difference is letter D. So the common difference is 2. So in getting the common difference, the formula is the preceding term minus the previous term. Preceding term 4 minus the previous term 2, that's 2. Preceding term 6 minus previous term 4, that is 2. Preceding term 8 minus previous term 6, that is 2. Or the second term minus the first term. The third term minus the second term. The fourth term minus the third term, and so on. And that's the way how you get the common difference. Therefore, the common difference is 2.
Now let us summarize everything about arithmetic sequence. Okay, the definition of arithmetic sequence. It is a pattern of numbers that increase or decrease at a constant amount. And that constant amount is what we call the common difference. What are the characteristics or facts of arithmetic sequence? It is or it has common difference or the constant amount. And we will denote common difference as letter D. And what are the examples of arithmetic sequence? In this sequence, 1, 4, 7, 10. So the common difference is 3. Since it is increasing sequence, so the sign of the common difference is positive. Or again, by getting common difference, we will subtract 4 minus 1, 3, 7 minus 4, 3, 10 minus 7, 3. Another example for arithmetic sequence, we have the sequence 10, 7, 4, 1, and the common difference is negative 3. Because this sequence is decreasing, so the common difference is a negative 1.
So then we have negative 3. 7 minus 10, that's negative 3. 4 minus 7, that's negative 3. 1 minus 4, that is negative 3. And how about the non-examples of arithmetic sequence? We have 2, 4, 8, 16. This is non-examples of arithmetic sequence because when you subtract 4 and 2, that's 2, 8 and 4, that gives you 4. So they're not common, or they're not the same, so therefore this sequence is not, or non-examples of arithmetic sequence. And this is also a non-examples of arithmetic sequence because 1 minus 1, that is 0, 2 minus 1, that is 1, 3 minus 2, that is 1, 5 minus 3, that is 2. The difference are not the same or not common, therefore this is non-example of arithmetic sequence. Okay, now let's have these process questions. How did you determine the examples and non-examples of an arithmetic sequence? By simply identifying its common difference. If the difference are common or the same, then it is an arithmetic sequence. If not, then it is non-examples of arithmetic sequence. Then how will you know that a given sequence is arithmetic or not? Still common difference. Okay?
This time, let's have activity. Let's try to check your skills in identifying arithmetic sequences. I have here 5 sequences, different sequences. Among the 5 sequences, let's identify how many are arithmetic. And if it is arithmetic, provide the common difference. Okay, let's start with number 1. 12, 16, 20, 24. Is this an arithmetic sequence? Yes. And what is the common difference? The common difference is positive 4. Since the sequence is increasing, so it will give you a positive common difference. And by checking the common difference, you will just subtract 16 minus 12, that is 4. 20 minus 16, that is 4. 24 minus 20, that is 4. Now let's proceed to number 2. 35, 32, 29, 26. Now let's check if this is arithmetic. Yes, this is arithmetic. What is the common difference? The common difference is negative 3. Since the arithmetic sequence is decreasing, so that is why the common difference is negative. Or simply apply the formula on getting the common difference. 32 minus 35, that's negative 3. 29 minus 32, that's negative 3. 26 minus 29, that's negative 3. So far so good. Okay, number 3. 40, 45, 50, 53. Is this an arithmetic sequence? No, because in the last 2 terms, when you subtract, it will give you a difference of 3. While the rest has a difference of 5. They are not common, therefore this is not an arithmetic sequence. Okay, how about number 4? Negative 3, negative 23, negative 43, negative 63. Is the sequence arithmetic? Yes. What is the common difference? That is negative 20. Since the sequence is decreasing, so how about number 5? 4, 9, 15, 22, and so on. So this is not an arithmetic sequence because the differences are not the same. Because 9 minus 4, that's 5. 15 minus 9, that's 6. They're not the same, so that is not considered an arithmetic sequence. Now that you have already learned about arithmetic sequence, it's your time to answer the activity sheet number 1 by yourself. I want you to go to your Google Classroom and answer the activity. Okay, that's all for today, and thank you so much for listening. And I hope you had a great time. See you next week. Bye.